stitch this video in with the previous one. Alright, I'm back. I'm sorry about that. It's about image distance and object distance and when they're positive and when they're negative, and the same for focal point. And I'll dedicate the last video entirely to that table, just something you need to memorize. It's super easy, and I'll go through it one more time. I wasn't even thinking about it when I did it. And also the concave lens or diverging lens. The negative signs were off, but it mathematically worked out anyway. And because it lined up with what we were expecting, it didn't send off any bells. So I'm really glad we hit this. So if you want to go back to that, the focal length in that should be negative. And if it's we'll dedicate the last video to it. But suffice it to say that because it's a virtual, or I'm sorry, not a virtual image. Yes, virtual image means that the image distance is negative. And because it's a scattering lens or mirror, in this case a convex mirror, that means the focal length is also negative. So when we're solving for the image distance, 1 over SI, negative 1 over SI equals negative 1 over focal point minus 1 over the object distance. And because there are so many negatives in this, I'm actually going to work through the math together. Negative, negative, negative becomes positive, positive, positive. So 1 over the image distance equals 1 over the focal length, which we found to be, or know is 1 over 2 meters, plus 1 over the object distance, which was 4 meters, 1 over 4 meters, and that's going to give you 3/4 of a meter, and when you solve that out, 1/2 plus 1/4 3/4, 1.33 meters for the object distance, which is excellent. That's exactly where we expect it to be, based on our ray diagram. So good on that. We still have to calculate magnification. Magnification is absolute value of hi-ho, image height over object height, but we don't have those. So it's SISO, image distance over object distance. Getting worn out. 1.33 meters over the object distance, which we solved to be, or we were provided with 4 meters. 4/3 divided by 4, it's going to be 1/3, 0.33333. So the magnification equals 0.33, or 1/3, and 1/3 of our object height is going to give us exactly 1 meter. So both of our estimates from our ray diagram are perfect. In the next video, we'll talk about positives and negatives. I'm really sorry that it was wrong in the other video and that I led you down the wrong trail on this one, but everything else, as far as I know, and I'm doing my best, is good. So in the next video, we'll clean up positives and negatives for images and focal length.